Good afternoon, students. So we are discussing mechanical properties of fluids today. Yesterday we have completed solids. Yes. So in the fluids, we will discuss about the Pascal's law, hydraulic pressure, hydraulic lift, Bernoulli's principle, main ಇದೆ ಇದರಲ್ಲಿ Bernoulli's principle, Bernoulli's application, equation of continuity. Correct. So here we have the first question. Which of the following statement is correct? Only solid have the fixed volume. Solids and liquid have the fixed volume. Both solid and liquid does not have a fixed volume. Liquid have fixed volume, but solids and gases does not have the fixed volume. Which statement is correct? Very simple question. Yes, answer. It is option A, right? Which is the correct statement. Both solids and liquid does not have the fixed, both have the fixed volume. Yes, volume is fixed for both, but the shape is fixed only for the solids, right? So here, volume is fixed for both, that is solid and liquid. Option B is the correct answer. Go for the next question. Which of the following statement is about 10 times smaller than that of the solid? The shearing stress of fluids is about 100 times smaller than that of the solids. The shearing stress of fluids is about 1000 times smaller than that of the solid. The shearing stress of fluids is about million times than that of the solid. Option D is correct answer here, students. The shearing stress of fluids is about million times smaller than that of the solid. So go for the next question. Pressure applied to an enclosed fluid is transmitted undiminished to every point of the fluid and the walls of the containing walls vessel. This law was first formulated by, yes, whose statement it is? Reynolds, Bernoulli, Pascal, Torsil. It is option C, that is, it is invented by the Pascal. Okay. Next question. Which conversion is correct in the given following? 1 atmosphere is equal to 1.01 into 10 raised to 4. 1 mm is of Hg is equal to 133 Pascal. 1 bar is equal to 10 raised to 7 Pascal. 1 torr is equal to 10 raised to 2 Pascal. Which one is the correct here? Yes, students, which conversion is right here? So it is option B, that is 1 mm of Hg is equal to, because 1 atmosphere is equal to 1.01 into 10 raised to 5 Pascal agatte, avaru kottidare 10 raised to 4 anta. 1 mm of Hg is 133 Pascal. 1 bar is equal to 10 raised to 5 Pascal ide, kottirodu 10 raised to 7. 1 torr is equal to 133 Pascal, but here it is given as 10 raised to 2 Pascal. Hope so you understood this, all the conversions. Yes, go for the next. Pressure is a scalar quantity because, yes, pressure is a scalar quantity because it is the ratio of force to the area, and both force and the area are vectors. The ratio of magnitude of the force normal to the area. Which option is right here? Yes, why it is a scalar quantity, students? See here, that is the pressure is a scalar quantity because it is the ratio of the component of the force normal to the area, and it is independent of the size of the area chosen. Okay, so it is not depending on the size of the area chosen here. Therefore, option C is the correct answer in the given question. Pressure at a point inside a liquid does not depend on. Yes, pressure at a point does not depend upon the nature of the liquid, shape of the container, the depth of the point, acceleration due to gravity. Yes, pressure inside a liquid ಯಾವ factor ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ, which does not depend on which factor. No, please it does not depend on the shape of the container. Okay, it depends on the nature of the liquid, it depends on the depth, and it depends on the acceleration due to gravity, but it does not depend on the shape of the container. In the next question, the two femorous each of cross sectional area 10 centimeters square support the upper part of human body of mass 40 kg. The average pressure sustained by the femurs is, yes, you need to calculate the pressure. So as you know that pressure is force by area. So it is force divided by area. Force is 400 because if mass is given as 40 kg, acceleration due to gravity is 10. Therefore, it becomes 400 divided by area is 2 into 10 centimeter square is there. Therefore, it becomes 2 into 10 into 10 raised to minus 4. That is 20 into 10 raised to minus 4. So substitute, we will get option C. Copy down the solution. We will go for the next question. Let's take this question. A 50 kg girl wearing heel shoes balances on a single heel. The heel is circular with a diameter 1 centimeter. The pressure exerted by the heel on the horizontal floor is. Again, you need to calculate the pressure. See. Try this, students. Yes. So pressure is equal to force by area. Force is equal to mg. Area is pi r square. So pi, keep it as it is. Instead of radius, they have given the diameter. So it is d by 2 whole square. So if you simplify, option C is the correct answer. Yes, check, students. So ಇಲ್ಲಿ d by 2 ಇದೆ. So ಹಾಗಾದ್ರೆ 4 ಆಗುತ್ತೆ. It becomes 4 mg divided by pi d square. So 4 into 50 into 10, 3.14 into 10 raised to minus 2. Substitute, you will get option C. Go for the next question. Two syringes of different cross section filled with water are connected with a tightly fitted rubber tube filled with water. Diameters of the smaller piston and the larger piston are 1 centimeter and 3 centimeter respectively. If a force of 10 Newton is applied to the smaller piston, then the force exerted on the larger piston is. So you need to calculate the force exerted on the larger piston. This is based on the hydraulic lift concept. That is F1 by A1 is equal to F2 by A2. So F1, F2 are the forces, A1, A2 are the so F2 is equal to area pi r square again. So substitute the values, all the values are given there. And F1 force is given as therefore F2 is equal to 90 Newton C. So very simple question based on the formula. Okay, in the previous question, so here what you have calculated, that is force is 90 Newton on the other side. In this question, if the smaller piston is pushed through 6 centimeter, how much does the longer piston move out? Here you need to calculate the distance. See. So here you need to calculate distance. So according to the equation of continuity, we can use that is A1L1 is equal to A2L2 as the water is considered to be incompressible. So volume covered by the inward movement of smaller piston is equal to volume covered by the outward movement of the larger piston. So therefore A1L1 is equal to A2L2. Correct. So here they have asked you to calculate L2. L1 value is given 6 centimeter and here the value of L2 will be 2 by 3. Here next question. To what height should a cylindrical vessel be filled with a homogeneous liquid to make the force with which the liquid pressure on the sides of the vessel equal to the force exerted by the liquid on the bottom of the vessels? Yes. Equal to the radius, less than the radius, more than the radius, 4 times than of the radius. See here, if h is the height, then here the force on the bottom is given by, that is force is equal to m into, here we are writing force in terms of density and area, that is it becomes rho gh into pi r square. Then the force on the vessel is given by, the height is they have given it as half than that of that. Therefore rho g into bracket h by 2 into 2 pi rh, because the vessel shape, the area we are taking it as what, 2 pi rh. So therefore here if we equate these two equations, we will just get it as what, r is equal to h. Next question. The next question is based on the YouTube container water and the methylated spirit, which is separated by a mercury. So here you can see water and the spirit is separated by the mercury. The mercury column in the two arms are at the same level with 10 centimeter of water in one arm and 12.5 centimeter of spirit in the other arm. What is the value of the relative density? Yes, you know how to do this one? B. Yes. So here you can see that students, that is the pressure due to the water is equal to pressure due to the air column. The pressure is given by rho GH, which is equal to rho GH. So one side it is with respect to the water, one side it is with respect to the spirit. Okay. So G, acceleration due to gravity on both the side, it will get cancelled. Therefore, we are getting the density is equal to, for the spirit, it is HW, water height, divided by the height of the spirit into density of the water. So which is equal to, the relative density is just given by the ratio of those two. That is rho S divided by rho W is equal to HW divided by HS. So the height ratio is given 10 divided by 12.5. So simplify, you will get it as 0.8. Option B is the answer. C. Is the next question. So in the previous question, if 15 centimeter of water and the spirit are further poured into a respective arms of the tube, the difference in the level of the mercury in the two arms is. So here what you are doing, that is 15 centimeter of water and spirit each are further poured into the respective arms. ಮತ್ತೆ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, 15 centimeter ವರೆಗೂ water ಮತ್ತೆ spirit ಅನ್ನು add ಮಾಡ್ತಾ ಇದ್ದೀರಾ. Then the difference in the level of the mercury in the two arms is. Here the relative density is given, that is 13.6 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So now what happens, the height is increasing. So first it was 10, now it is plus 15 into rho GH. The pressure you are getting it as what, 25 gram for the water. And for the spirit, the initial height is 12.5 plus 15. And if you simplify, the pressure is 22 into G you are getting. Okay, so we are not substituting the value of G here, because if we take the ratios, it will get cancel itself. Now here the difference in the pressure they are asking, therefore P1 minus P2 is equal to rho GH. So P1 is 25G, P2 is minus 22G, which is equal to H into 13.6, the density which is given in the question, into G. So G will get cancelled on both the side. 25 minus 2 is 3. 3 divided by 13.6, it is 0.22 centimeter. The next question, students. In the wind tunnel experiment, the pressure on the upper and the lower surface of the wings are 0.9 into 10 raised to 5 Pascal and 0.91 into 10 raised to 5 Pascal. If the area of the wing is 40 meters square, the net lifting force on the wing is. Yes, you need to calculate the value of the force. Yes, the pressure difference provides the lift, that is equal to, so pressure difference into area. So pressure difference P2 minus P1 is equal to, the pressure value is given in the question, into area is 40 meters square. Correct. Therefore, the answer is 4 into 10 raised to 4 Newton. Option B is the correct answer. C. The next question. Three vessels A, B, and C of different shapes contain a water up to the same height as shown in the figure. The pressure is given exerted by the water at the bottom of the vessel A, B, C respectively. Then, yes, what will be the pressure? Only the thing is what the shape of the container is different, but the level of the water is same in all. What will be the pressure? L pressure ಜಾಸ್ತಿ ಇರುತ್ತೆ or the pressure will be less or the pressure will be equal. So this is this paradox concept. So according to the paradox concept, see here, it is equal, students. See, pressure at the bottom is independent of the area of the base of the vessel. It depends on the height of the water up to which the water is filled. As in all the three vessels, the level of the water is same. Therefore, the pressure will be equal. Okay, adana paradox anta ಹೇಳ್ತಾರೆ. Such type of shaped objects. Which one of the following instrument is used for measuring the gauge pressure? Yes, which instrument is used? Thermometer, barometer, manometer, hydrometer. Yes, barometer or manometer. So to measure the difference in the pressure, we are using manometer. The pressure can be measured with the help of the barometer. So difference in the pressure ge gauge pressure anta ಹೇಳ್ತೀವಿ. Gauge pressure is measured by the help of the manometer. Here you can see the barometer is used to measure the atmospheric pressure. Manometer is used to measure the gauge pressure. Gauge pressure andre difference in the pressure. Hydrometer is used to measure the relative density of the liquid. Let's go with this question. A manometer reads the pressure of a gas in an enclosure as shown in the figure. Okay, you can see the figure here. It is a manometer. The absolute and the gauge pressure of the gas in centimeter of mercury is. The absolute and gauge pressure of the gas in centimeter of mercury is. You need to take the atmospheric pressure is equal to 76 of centimeter of mercury. Yes, the absolute and the gauge pressure. So here you can see the pressure head is equal to, here the atmospheric pressure is 76 mmcm of centimeter of mercury, which is given. So from the figure, the height is given as 20 centimeter. The absolute pressure is given by P plus H. So P is 76 plus H is 20, therefore 96 centimeter of mercury agate. But the gauge pressure is 20 centimeter of mercury. Okay. Yes, tell me this answer, students. The pressure at the depth H below the surface of the liquid of density rho open to the atmospheric pressure is. What is the expression? Yes, students. It is option A, greater than the atmospheric pressure by rho GH, because allen ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ we add that term, the atmospheric pressure and the normal pressure, we add the values there. Okay, so therefore it is greater than that ಅಂತ ಹೇಳ್ಬೋದು. Let's calculate this one. The force acting on the window of area 50 by 50 centimeter of a submarine at a depth of 2000 meter in an ocean, the interior of which is maintained at sea level atmospheric pressure is. So the density of the sea water is 10 raised to 3 kg per meter cube. G is equal to 10 centimeter, 10 meter per second square. So density is given, acceleration due to gravity is given, height is given, area is given. Just you have to calculate the force. Yes, calculate and tell me what is the answer. Pressure is equal to force by area. So ಏನೇನ್ modify ಮಾಡ್ಬೇಕಾಗತ್ತೆ ನೋಡಿ ಅದರಲ್ಲಿ. Yes, what is the answer? So very simple question. CH is equal to 2000 meter. Density is, if it is water, you have to understand if it is not given also. Water density estirutte 1000 irutte. So therefore 10 raised to 3 kg per meter cube. And acceleration due to gravity is 10 meter per second square. So pressure outside the submarine P is equal to PA plus rho GH. And the gauge pressure is given by P minus PA, which is equal to rho GH. So therefore, you substitute the density, acceleration due to gravity and the height value. The gauge pressure you are getting it as what? 2 into 10 raised to 7 Pascal. Okay. Area is given 50 by 50. Therefore, it becomes 2500 into 10 raised to minus 4 meters square. Force acting on the window is given by. So, force is equal to pressure into area. So, the pressure is 2 into 10 raised to 7 and area is 2500 into 10 raised to minus 4. So simplify, you will get force as 5 into 10 raised to 6 Newton. Let's copy down this. We will go for the next question. Yes, next question. A tank with a square base, area 2 meters square, is divided into two compartments by a vertical partition in the middle. There is a small hinged door of the face area 20 centimeters square at the bottom of the partition. Water is filled in the one compartment and an acid of relative density 1.53 into 10 raised to 3 kg per meter cube in the other, both to the height of 4 meter. The force necessary to keep the door closed is, what is the force is required to keep the door, a partition door and a close ಇಡಬೇಕಾದ್ರೆ ಎಷ್ಟು force ಬೇಕಾಗುತ್ತೆ? Yes, the next here. What you need to do, that is See the force necessary to keep the door closed. The force you need to calculate. To calculate the force, here the pressure exerted by the acid is given by the density of the acid, and the height is 4 meter and acceleration due to gravity is 10. So it becomes the pressure exerted by the acid is 6 into 10 raised to 4. The net pressure on the door is given by PA minus PW. So PA value is 6 into 10 raised to 4 minus the water pressure is 4 into 10 raised to 4. The difference in the pressure becomes 2 into 10 raised to 4. And the area of the door is given as 20 centimeters square. So that is 20 into 10 raised to minus 4 meters square. Okay. The force on the door becomes, so what is the force here? The force is given by pressure into area. So pressure is 2 into 10 raised to 4 and area is 20 into 10 raised to minus 4. Correct. Therefore, the force becomes 40 Newton. Thus, to keep the door closed, the 40 Newton force must be applied. Go for this question now. So here you have some iron beads are embedded in wax ball just to floating in water. The volume of the ball is 18 centimeter cube and the relative density of the wax is 0.9. The mass of the iron trapped in the ball is. Yes, let the mass of the iron trapped is nothing but the weight which is equal to upthrust. So that is given by m plus mass of the wax into acceleration due to gravity. Ignoring the volume of the iron since it is in the form of the small beads. So therefore it is m plus 18 into 0.9 and here it is 18 into 1. Therefore m becomes 1.8 gram. Next question, hydraulic brakes are based on Pascal's law, Torsil's law, Newton's law, Boyle's law. Very simple question. It is based on the Pascal's law, right? Hydraulic brakes. Yes, this one question, students. Last question for today's class. Iceberg floats in sea water with a part of it submerged. The percentage fraction of the iceberg submerged is density of the ice is 0.9, density of the sea water is 1.1. So the percentage fraction of the iceberg submerged is Yes. Here you can see the percentage submerged is, it is given by, let V is the volume of the iceberg. Okay. So here the iceberg floating in the sea water, then V rho G is equal to, that is X percent, suppose X part dip agide anta ನೀವು consider ಮಾಡಿದ್ರೆ V minus X rho into G. Okay, so therefore V into 0.9 into G, which is equal to V minus X. Yes, so here it is V into 0.9 into G, which is equal to V minus X into 1.1 into G. So calculate. So the X by V, that is the percentage of fraction of the volume of iceberg above the level of the sea water, is 18%. See. So X by V is equal to 0.2 by 1.1 you are getting. So multiply it by 100, you will get it as 18%. Yes. So this completes on the mechanical properties of fluids. Okay. So we will meet in the next class. Have a good day, students.